Okay, and the last lesson for conics is 8.4, hyperbolas. A hyperbola is the set of all points in a plane whose distances from two fixed points in the plane have a constant difference. So let's go ahead and put this here. We're just going to go ahead and look at the vocabulary. They tell us this at the top. You know you can read that. The fixed points are the foci of the hyperbola. The line through the foci is the focal axis. The point on the focal axis midway between the foci is the center. The point where the hyperbola intersects its focal axis are the vertices of the hyperbola. So verbally, let's look at that vocabulary. The point on the focal axis midway between the foci is the center. We're basically just using that information above to fill these out. The foci, plural for focus, are the fixed points equidistant from the center. So equidistant from the center and located on the focal axis, which is our major axis. The vertices are the points where the hyperbola intersects its axis. A chord is any line segment with endpoints on the hyperbola. The chord lying on the focal axis connecting the vertices is called the transverse axis. And it's the distance of 2a, which we're going to see in just a minute. The conjugate axis is the line segment of length 2b that is perpendicular to the focal axis with the center of the hyperbola as its midpoint. The number a is the semi-transverse. I can actually write this on one line. Semi-transverse axis. And the number b, whatever that number is the semi-conjugate axis. Okay, so looking at the pictures, I know all these words, a lot of times some of these are new. It's difficult to understand the wording. The focus would be like that point here. This is a focus. Same thing for this little piece right there. This is the center. The vertex would be that point right there. And right there. Looking at this other one, might be easier to draw the lines. The distance on this piece is a distance of a. And it's the same on this side. Okay, so that's where you get the 2a. Then you go up, and actually this makes like a rectangle here. Which tells it the curve that it goes through. And this would be a distance of b on each side. B here. B up, I mean. B distance up and down. Because that would be negative b in that part. The conjugate axis is this one. And the semi-transverse axis would be there. Okay, so let's look at these problems in a little bit more detail. Oops. Okay, so Wow, we're keeping going. I gotta hurry it up. Okay, so on this one, why is it not working here? There we go. Okay, how to sketch the hyperbolas. So notice that we've got two different examples here. One going either direction. It could go, through the x-axis or through the y-axis. The first part we're going to look at is the equations when the hyperbolas have a center of 0, 0, because those are... So the hyperbolas with center of 0, 0, for the first one here, we would have x squared over a squared minus y squared over b squared equal to 1. If you were looking at the other one, that second one there, that's going to be y squared over a squared minus x squared over b squared equal to 1. So notice how similar they are. The negative thing is what is different. The focal axis for this first one is the x-axis, because it's going through the x-axis. For the second one, it is the y-axis. The foci here would be the positive or negative c value, and 0. This one would be 0, and then a positive negative c for the y. As far as the vertices go, for this first one, it's plus or minus the a value, and then 0. This one's 0, and plus or minus the a, because it just depends on whether it's through the x-axis or the y-axis. The semi-transverse axis on both of these would be a. The semi-conjugate would be the b. The Pythagorean relation is basically the same as Pythagorean theorem, where you have a squared plus b squared equals c squared. That's the same thing. A lot of times here it's written backwards like this, but either way it's the same. And then if you notice, like when you look up here at this picture, you see how they have these asymptotes. Those red dotted lines are the asymptotes. The equation of those lines, as you can see, and it's in the picture, but these asymptotes have the equation of y equal to a plus or minus b over a x. This one would be y equal plus or minus a over b x. And the reason those are different is because, remember, the slope is always rise over run, so it's like the y value over the x value, just depending if it's lettered A or B. It really doesn't matter as long as it follows regular slope. Okay, so now let's look at actually working some of these out. Like, what are you going to see these as problems? So in example 1, it says find the vertices and the foci of the hyperbola. So if we look at this and we see that it's not in the proper form, for instance, there's no 1 on the outside there. So what you first want to do is divide everything by 144 to get a 1 out there. So this is going to give me x squared over 16 minus y squared over 9 equal to 1. Now it's in the proper form. So we know that remember that's a squared, or is 16. So I know a squared plus b squared is equal to c squared. So I've got 16 plus 9 equals c squared. So c is 5. All right, so when I'm looking for the major vertices, this is going to be negative 4, 0, and 4, 0. The minor ones would be 0, negative 3, and 0, 3. And then the foci would be negative 5, 0, 5, 0. A lot of times if you graph it, it helps you to see that easier than like memorizing it. So if you need to do that, I totally understand. Let's look at example 2. We're actually going to graph this one. So if they give us the equation, and notice it's in the proper form, then I know that a has to be 4, because remember that's the square root. It's the square root of 16. 16, square root of 16 is 4. B would have to be 3, so then I have to solve for C. Well, actually, that's the same thing as basically what I just did, so I know that's 5. HK. Now, I wonder why they showed this one here, because they didn't do the equation for that just yet. But basically, this is 0, -2. It's the same format as what we did before with the circle and the parabola and all that kind of stuff. Because this one has, you know, something with it, it's y minus k, which I don't know why they had that example first, but oh well. Okay, so the foci means, actually, you know what, let's just draw this first. If I know it's at 0, -2, then this is my center, okay? On the x-axis, I have to go 4 over each direction. So 1, 2, 3, 4, 1, 2, 3, 4. On the y-axis, I have to go up 3 and down 3. So 1, 2, 3, 1, 2, 3, like that. And then I'm going to draw like just a little box, you know, it's like dotted lines here to make this box. So I know my asymptotes are going to go through the corner of these things, like this. It's easier if you have like a straight edge and you can do this on paper. All right, so that's what it looks like. So then when I draw my actual hyperbola, it's going through that point, but it kind of curves around these edges. That's how you know where the curve is. It doesn't touch those, remember, because those are asymptotes, but it curves around the edges like that. It's going to go through the x-axis because x had the bigger number underneath. Okay, so the foci, that's the one with 5. So I'm adding a 5 to the x here. So -5, -2, and 5, -2. I'm adding and subtracting that. Now, when I go to look at these asymptotes, that's the dotted lines I just drew. Remember, you're still doing like slope, you know, okay? You're still looking at y = mx plus b. So here I know y is equal to a positive or negative, and the slope, let's see, would be 1, 2, 3, 1, 2, 3, 4. So up 3, right, 4, and then b is -2. So you can write it together like that as one equation. If you want to write it separate and write two separate equations, then you would say 3/4 x minus 2 and y = -3/4 x minus 2, if you wanted to. All right, let's look and see what the next page has in store. Okay, so on this one, these are what the hyperbolas look like if the center is not on the origin. Okay, it's very similar to what we've done before. We're building on that, that same equation format. So this is going to be x minus h squared over a squared minus y minus k squared over b squared equal to 1. As far as if it's going through the y-axis, then the y one goes first. But otherwise, the equation is the same. The a's and b's, you know, are with the first one. The a squared goes with the first one, b squared with the second. Okay, as far as the focal axis here, the focal axis is going to be y equal to k and x equal to h correspondingly. The foci would be h plus or minus c, and then k. Over here would be h, and then k plus or minus c, because remember our center is hk, so we're adding c to that x or y value depending on which direction it's going. For the vertices, this is h plus or minus a, and k. This would be h and then k plus or minus a. The semi-transverse axis is a for both of these, because that changes depending on which one it is. The semi-conjugate is b. The Pythagorean relation is the same. A squared plus b squared is equal to c squared. And the asymptotes are very similar. The only difference is we're not going to rewrite it in slope-intercept form. We're going to leave it in point-slope form. So you get y minus k equal to plus or minus, and the slope is going to be the y portion over the x portion, you know, the change in y over the change in x, times x minus h. So it's very similar to what we've done before. There we go. All right, so let's see how that's used. Okay, so in example 3, they're giving us the graph and they're asking us to write the equation for the hyperbola. So let's do that. Let's look at our picture and figure out what's what here. So I'm noticing right off the bat, actually let me go to that, okay, that it's going through the x-axis. So that means the x part goes first. So notice there's 1, 2, 3 here. So that means that this A is 3. Then when I look at the y part, this is 1, 2, 3, 4, distance of 4 up. So then I know that this is 4. So right off the bat, I think I have enough to write my equation. Oh wait, I need the center. What's our center here? Center is 2, 1. HK is 2, 1. That's our center. So I've got x minus 2 squared over 9 minus y minus 1 squared over 16 equal to 1. So I've got my equation. So that wasn't too bad as long as you know the form of the setup on there. Okay, so we need to find C. Well, basically, isn't that the Pythagorean triple of 3, 4, 5? If not, you would use your a squared plus b squared equals c squared just to confirm. But that one comes out to be a Pythagorean triple. As far as the foci, oh, let's see. That means it's going to be 5 over from that center. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, right? On either side of the center, going in the direction of the hyperbolas. So let's see, that would be 7 and 1, and the other one would be -3 and 1. Sometimes it helps to draw it out before you just try to do the math on it. Okay, and then the asymptotes. Now look at our slope of these asymptotes. Let me change a color here. The slope would be, they went up 1, 2, 3, 4, 5, 6, 7, 8. Okay, sorry about that. The generator kicked on, so I had to move from outside to inside to get out of that noise. Anyway, so our slope on this one, notice, is a positive and negative 4/3. So that means we have y minus 1 equal to a positive and negative 4/3 times x minus 2. All right, so let's look at example 4. Find the equation in standard form for hyperbola whose transverse axis endpoints are -1, -3, and -1, 7, and the conjugate axis length is 8. Wow, okay, so let's see. Well, transverse axis. So we know the center is halfway between these 2 points. So I'm going to go ahead and put these 2 points on here. So -1, -3, that would be here. And -1, 7 would be here. All right, so right in the center, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 spaces. So halfway in the middle would be 1, 2, 3, 4, 5. So that's our center. Our center, we know, is -1, 2. Conjugate axis length, and actually if that's 5 and 5, then I know A would have to be 5 here, right? Then, let's see, the other one, the conjugate axis length is 8, so that would be 4. No, yes, because that's 2. Okay, so then I have to go over 1, 2, 3, 4. 1, 2, 3, 4. All right, so that contains my little box, like that. Okay, so, this is interesting, isn't it? So if the y is taller, then that means that one, I think it's going through there, right? So if I draw my lines of my asymptotes, we got this going this way, got one going that way. It's kind of hard to do this without a ruler and a straight edge. I'm sure you guys are doing much better than mine, as it can be. So I know it's got to go like this. So we finally got one going the other direction. Oops, kind of messy, but you get the idea. All right, so if I wanted to find C, then I know I've got to do a squared plus b squared equals c squared. So 25 plus 16, that's what, 41? So this is square root of 41, which is about 6.4. So 1, 2, 3, 4, 5, 6.4. So somewhere up in there. 1, 2, 3, 4, 5, 6.4, somewhere up in there. That makes sense. Okay, so our equation, since it's going through the y is first. Y minus 2 over 25 minus x minus, plus 1, right, over 16 equal to 1. Does that look right to you? Alrighty, so that gives us foci of, let's see, if we add 6.4, then that's -1 and 8.4 about, and -1. If I subtract it, that's -4.4 about. Okay, our asymptotes. Slope here is up 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, so y minus 2 equal to a positive or negative 5/4 times x plus 1. There we go. Okay, so on our last page here we have example 5, and this tells us about eccentricity, and that is denoted by that little e, and that's equal to the relationship or the ratio of c over a, where a is the semi-transverse axis, b is the semi-conjugate axis, and c is the distance from the center of the hyperbola to either focus. So in example 5, prove that the graph of the equation is a hyperbola. Find its vertices, foci, asymptotes, and eccentricity. All right, so we're going to use completing the square. Hope you're ready for that. Okay, so first we're going to put the x's together here. So now I've got 4x squared minus 16x. I'm going to go ahead and put plus c, minus 9y squared minus 72y plus d equal to, and I'm going to bring the 164 over, like that. So I'm kind of grouping my x's together, grouping my y's together. To be able to do completing the square, I have to have a coefficient of 1 with the leading coefficient here. So I'm going to factor out a 4. And then c in this case would be 4 divided by 2, which is 2. 2 squared is 4. Here I'm going to factor out a -9, so I get y squared minus, no, plus 8y. Half of 8 is 4. 4 squared is 16. So on the other side, since I added 4, but it's 4 times 4, so this is 16, And then I had to take away 9 times 16, which is 144. So just be careful on, on this piece. Because remember, I'm saying this times that and this times that on that side. Okay, so just be careful with that. All right, so this would give me 4, and then x minus 2 squared minus 9 times y plus 4 squared equal to, that gives me 36. Okay, so we're getting close, almost done here. So last step here, we need a 1 on the outside, so we're dividing everything by 36. So that leaves us x minus 2 squared over 9 minus y plus 4 squared over 4 equal to 1. All right, so now it's in the proper form. So we have proven that this is a hyperbola. So our center here is 2, negative 4. A is 3, B is 2. So when I go to find C, 9 plus 4, so C is the square root of 13. So our major vertices then would end up being 5, negative 4, and negative 1, negative 4. Our foci would be 2 plus square root of 13, and negative 4, and 2 minus the square root of 13, negative 4. Let's see, asymptotes. This will be y plus 4 equal to positive negative 2/3 times x minus 2. And then since this E is C over A, we get square root of 13 over 3. And if you plug that in your calculator, I think it's about 1.202. All right. I hope you enjoyed the lesson.